The position vector r meters of a particle p of mass 3 kilograms relative to a fixed point O is given by r is 5t squared minus 2t, t cubed. We want to find the speed of p when t equals 5, the acceleration vector when t equals 10, and the magnitude and direction of the force on the particle when t equals 2. So for part A, we want speed. That means we need velocity, and this is displacement. So we're going to differentiate. So differentiating 5t squared minus 2t gives us 10t minus 2. Differentiating t cubed gives 3t squared. V of 5 then, just substitute t equals 5 in, is 10 times 5 take away 2, and 3 times 5 squared, which gives us 48.75. We want speed, and so we use Pythagoras' theorem to work out the magnitude of the vector, and so we have the square root of 48 squared plus 75 squared, which is 89.0 meters per second, correct to 1 decimal place. Now we want the acceleration vector when t is equal to 10. So we need to differentiate velocity. So that's going to give us 10 and 6t. So A of 10 is 1060. We want the magnitude and direction of the force on the particle when t equals 2. We know that force is equal to mass times acceleration. So F of 2 is going to be 3, and then the acceleration at t equals 2 is 10 and 6 times 2, which is 3 times 10, 12, which is 30, 36. So if this is 30 in this direction and 36 in this direction, then the magnitude of the force is going to be the square root of 30 squared plus 36 squared, which is 46.9 newtons to 1 decimal place. And if we want this direction, tan theta is 36 over 30, and so theta is 50.2 degrees to 1 decimal place. So we could express that as being 50.2 degrees to the vector I.